Speed addiction. I'm here to talk about, well, actually, you guys and your addiction to speed. Because I asked you what you wanted to see for this Hazel devlog, and well, look at this fancy stuff popping up. It's because I got a new editor. It's, yeah, pretty cool. Gonna definitely make more videos now. Right, so it's been quite a while since I last made a Hazel devlog. Last time, I think when we released our last game for the Bottleneck game jam, which I'll have linked up there, that was like the last devlog, I think. In fact, I don't even think I really spoke about that game much. I don't know, it's all been a blur. I've been focusing on like other videos, doing some work kind of off screen that you'll see very soon. Just not being a good YouTuber, you know? Sometimes I gotta switch gears and be a software engineer or, I don't know, run the company, that kind of stuff. The rest of the team, though, have been working very, very hard. There's some really, really exciting stuff coming up for the second half of this year. We're almost ready to release Hazel 2023.2, which is like our second release for the year. I think really the truth is I'm just overthinking these devlogs a little bit. I just need to hit record and make it happen. I'm sure I'll come up with something interesting to say, hopefully. A bit of a risk there. What if I don't? Oh well, I'll just delete the video. So whilst I would like to update you kind of in detail into what's actually been happening behind the scenes, and I need to shed some light onto what the Hazel team's doing, I'll probably make a video later this month talking about that because you guys wanted to see some performance bottleneck discussion. Yes. No, I'm just kidding. I like that too. By the way, I want to quickly mention that Threads is a thing. I have a little Threads account here, and my kind of plan for Threads is to hopefully treat it as just like a really chill kind of Hazel devlog and I guess other projects I work on as well. So definitely follow me there if you want to see like more casual updates as to what's going on with Hazel, because obviously it's easier for me to just type something on my phone, share a photo or something rather than making a video. Right. So what I have over here is a fairly recent version of Hazel. I think this is in my, Dev Renderer 2023 clean kind of checkout of Hazel. I have a lot of checkouts of Hazel, actually. Let's just quickly see how big my Hazel folder is. All right, there we go. 266 or 265, depending on, tomato, gig, 489,000 files. Right, yeah, definitely need to clean that up. This is a fairly recent version of Hazel, meaning that I don't think there are any other performance improvements that have gone into that. And what I've got here is the latest game that we shipped, Saving Captain Cherno, just a little coffee delivery in a war zone type game. You know the genre. And what we can do is we can actually, so this is like the root directory of the game with the launcher and everything, but if you go into the actual Saving Captain Cherno folder here, this is like the folder with the executable. So what we can actually do is we can just grab this path and feed it in as the working directory to Hazel runtime. By the way, if you guys want access to Hazel and you want to support its development, patreon.com/thecherno. We've got an automated system now where you can just get access yourself. So in the past, people used to send me messages. I would take like up to a week to reply, and then I'd give them access manually. Now you just go to get.hazelengine.com. So basically, as soon as you do it, you just get access. If you want to follow along and play with Hazel and learn from it, as well as, support the team, support the development, then that's kind of, I guess, like the sponsor of this video, and thank you so much for your support. Huge thanks to Hazel for sponsoring this video. All right, so here in the working directory, just gonna paste that in. And now we can just launch this. I've got it in release mode. Probably shouldn't do any like benchmarking or whatever in debug mode, unless you're like optimizing debug, which is technically a thing because sometimes you don't really want your debug configurations to run too slowly. Anyway, so here we have the game. This is running. Now, I do want to quickly point out, actually, a quick disclaimer. I haven't actually tried this yet, but I'm sure there will be problems because this is kind of like, like if you shipped a game on Unity 2021 or whatever, and then you're trying to just play it with the Unity 2022 kind of runtime, or 2023, actually. What year is it? Like, there are obviously changes there, and I'm just like, I'm not actually even loading this in the editor. I'm just playing the runtime. So we'll see what happens here. Hopefully it doesn't crash, but it seems to be working. I want to kind of mute it. I wish we added something to mute the game kind of in-game. All right, I got my volume mixer here. So if I hit play game, okay, we got some sound here. Let me just mute that. Right, all right. Okay, so yeah, here's the game. This is quite a wild terrain generation thing. If we hit Control F3, we can kind of see the performance. So it looks like it's around 72 FPS here, which is a little bit lower than, I feel like lower than the actual shipped copy, which is fun. I mean, this is a release build, not a dist build. There's some optimization that goes into a dist build, but this does feel kind of slow. If we just take a look at the timers really quickly here though, we've got the render thread at 3 milliseconds, the main thread at 3 milliseconds, and this at 20 milliseconds. Okay, that's a bit weird. Maybe we just got a weird frame, but it looks like it's kind of jumping. If I leave it running, I mean, it's settling on 144. Maybe I just got like one dropped frame where it tried to load an asset or something. Okay, so 146, 7 mil. Okay, so this looks like a standard frame. So we've got the render thread here at 6.9 milliseconds. We've got the main thread at 3.7. 144 hertz is my monitor, which is why we're kind of locking at this. I could run this without VSync. In fact, I will, because that will just be a little bit better. So let's just go over here and make sure that VSync, which actually gets read in from here, but we can override it, I think. If we do VSync equals false here, that will just overwrite the actual kind of tiering settings file, which is like our configuration file. All right, let's take a look at this. Okay, so we spawned beneath the ground, which I'm guessing is just a consequence of the wrong runtime, because that doesn't seem to happen in the retail version. Keeps happening. Okay, I spawned above the ground. I literally had to run it 20 times. I think like something in our C# scripting API must have changed or something physics related. I don't know what it was, but I'm happy to get this spawn. Okay, so if we take a look, this is, I guess, without VSync. Let me just let it run for a bit. So 200 FPS-ish. Let's just kind of take a deeper look here. So main thread, 3 milliseconds, render thread 4. We're spending 5 on the GPU, so these timers are a little bit offset, obviously, because all the devices are running in parallel. Well, actually, I guess main thread is running in parallel, so render thread and the GPU is its own device, so that's kind of running in parallel as well. GPU wait 1.54 milliseconds, so if there's any time here at all, it means that we are waiting on the GPU to do something. Like the CPU cannot continue until the GPU has finished, which could possibly stall the main thread, but that also depends if the main thread has stuff to do or not. You can see here, though, it's waiting for the render thread, so it doesn't. So from kind of reading these timers, what we know is that ultimately we are GPU bound. Like the GPU is the bottleneck here. Because the render thread, which is on the CPU, that CPU thread is waiting 1.54 milliseconds, doing nothing except waiting for the GPU to finish its work, whereas it took only 2.84 milliseconds to run. So CPU only just means the actual C++ code running on the render thread. How long did that take? Empty wait is how long we had to wait for the main thread, which is nothing, which is basically how much of this time was spent simply doing nothing, waiting for the GPU to finish its work, because we can't kind of continue to the next frame. We're being held back by the GPU. And you can see the main thread is also waiting for 1.26 milliseconds because its workload is lower than the render thread. The render thread is taking more time. But again, that looks like it's a consequence of this, because the actual main thread time here, I wish I had like a without waiting, I guess, because this, I'm presuming, includes the actual waiting for render thread time. But either way, CPU-wise, we seem pretty okay here. Maybe the render thread is a little bit slower, but it's really the GPU here that's dragging us down. What it also means is that theoretically, we could give the main thread more work, right? Because if it's waiting, it's doing nothing. So 1.26 milliseconds worth of work can be put onto the main thread with no consequence to the overall frame time or frame rate. And with the render thread, 1.54 milliseconds worth of work can easily be put on there as well. So that's good, because when you're thinking about like optimization for a game, and obviously this is really difficult to do for engines, right? Because if an engine is meant to be like a general thing, like as in you're making something like Unity, which, you know, don't really think that's what we're trying to do here with Hazel, but in a way it is. Like Hazel can be used to make, I guess, any kind of game. Maybe not like super heavy photorealistic games, you know, like Unreal Engine 5, but in terms of like genres, you know, I don't really see any limitations there. And so obviously you can't really look at these numbers and be like, oh yeah, every single title in Hazel like is GPU bound or is render thread bound. Therefore we have 1.26 milliseconds of work that maybe we could take some stuff from the GPU even and just put it on that thread. Maybe there's a compute shader doing some kind of culling or sorting or whatever that we could maybe just put onto this main thread. Now, obviously the other thing to consider here is if you really are wanting to add more CPU work, you could kind of think about, well, how much of the CPU am I actually utilizing here? And the answer is, well, obviously not much. We have 2 threads here. Like there's an audio thread as well. And physics, I believe, can run on a separate thread, although in this build, I believe it's not. But my point is, if I have like an 8-core CPU, and I'm only really using 2 threads, then like maybe I can use more. And as I mentioned, that audio thread, because it's so light, like you could almost split that into 2 threads in a way. Like the CPU will schedule more work onto that physical CPU core because audio isn't occupying all of its processing power, if that makes sense. So you can kind of really think about like, okay, if I do in fact have something on the GPU that wouldn't be too slow to move onto the CPU because of the difference in architecture, then maybe I can just spin up another thread and have it do an entire like potential 5 milliseconds worth of processing, because you could effectively do that for free. Again, assuming it's something that can in fact run in parallel and isn't dependent on other things. And that's why, like, ultimately speaking, like a job system, like some kind of task graph with dependencies and all of that, that's really, really important for a game engine, because it lets you kind of distribute that workload where it's sensible to do so across the hardware that you have available to you. But the benefit of looking at this stuff is that, and this is, by the way, we're just looking at timers. Can I just point out that we are just looking at timers? If you guys are building your own tech, there is no reason why you can't just implement some timers. Like maybe the GPU timers are a little bit harder, which, I mean, we're not even looking at GPU timers here though, are we? These are all CPU timers. That actual 5.26 milliseconds of GPU time, I imagine that is an actual GPU timer. Maybe. I actually don't know. I'll have to look at the source code. But the rest of these are all CPU timers. We obviously have like deeper profiling tools available to us. We'll take a look at one of them in a minute. But it's just cool that there's so much kind of intel, there's so much information we can gather just by looking at these numbers that, again, are like really primitive in a way, right? There are also some things up here in the top right. This is just kind of like the overall CPU time, the overall frame time, and the overall GPU time. Again, some of these are one frame out of sync from each other, which is why some of the numbers might look weird. There's GPU memory usage, which is quite a bit because Hazel doesn't actually compress any textures at all at the moment, which is a bit weird. Even though it looks like the majority of our, oh, I know why. Yeah, okay. So while we're on the topic of this, so this buff means buffers. So GPU side buffers, we have 2.42 gig of them, which seems crazy, but it's actually because in this like version of the source code, just my locally checked out source code, this is gonna sound stupid, but in renderer 2D, in the 2D renderer, I just increased like the fixed size of like how many lines and quads you can render to like 5 million or something, because I needed to visualize stuff for the ray tracing series, and I needed to like draw many, many lines, like one for each ray basically, and lots of kind of other debug graphics, which is done through renderer 2D. And so I just added some zeros to like the buffer sizes. That's why they're huge. So I think this will be definitely under a gig usually. Because it is quite a bit. But images, you can see we're using 1.13 gig, and this is kind of like our current memory usage versus total memory usage. This would be including shared memory, because I think my 3080 only has 10 gig of dedicated memory. Anyway. Most of the timers though are over here, and these things ship, by the way, if you just hit Control F3. I don't know if you'll get all of the details because some of them, I guess, require the non-distribution build potentially, but this kind of is available in any Hazel game, although the later versions of Hazel are a little bit more detailed. Anyway, I feel like I went on a random tangent there. What were we talking about? Right, so actually optimizing this game though, see, this is the other thing. If you have a game, if you made a game, like with Hazel, for example, like let's just say this Saving Captain Cherno was a serious game that we wanted to ship on Steam, potentially even sell, and so it was obviously, this is the product, right? Yes, we made it with Hazel, but clearly our optimization efforts are for this game specifically. That is where this is really quite useful, because then you can go in and be like, yeah, that thing about making like another core for some work that maybe is even specific to this game, maybe I can do that. Maybe I'm not GPU bound. Maybe I can move some stuff over onto the GPU, do some processing there, or obviously vice versa. I can see that the GPU time is more here. Maybe for this game specifically, I can offload some of the work from there and move it to the CPU. The only thing I would say to that is obviously be careful, because if you're making PC games especially, like it's not like a console, like a PlayStation 5, for example, where you know the exact amount of cores you have, you know the GPU architecture, you know everything. You don't if you're on PC. Maybe on a 3080 with my, like, what do I have, like a 5950X, I think, AMD CPU, maybe on that setup, these are the numbers I get, and this is the bottleneck. But then on something else, on a different computer or on a laptop with integrated graphics, it could be completely different. And that's where the challenge comes in. You kind of have to balance this and make sure that you kind of provide a good experience across the board. And I think that's honestly one of the biggest challenges of trying to roll your own tech and make your own game engine, is the fact that like the support, you know, supporting a wide range of platforms and a wide range of just different hardware, even just on Windows 11 or Windows 10 or whatever, like Windows, I'm shipping on Windows. Sure, easy, right? No, because there's so many different GPUs. AMD GPUs are different to NVIDIA GPUs. What about Intel integrated graphics, right? You're gonna just cut that market out? Because Hazel actually at the moment, I don't think runs on Intel GPUs, or at least not like, and I'm talking, by the way, about integrated GPUs, not their kind of new dedicated ones. But my point is, like, there's all this kind of work that has to go into it. And, you know, we kind of, Studio Cherno, like, we wanna ship games on Steam eventually. Like, that's kind of our goal, right? We're making Hazel, and like, it's our passion. We love making game engines and we love working on Hazel, but we do want to use it to actually make something that we can ship on Steam. And that's a little bit scary because like we're gonna have to make sure that it runs on so much different hardware, and I guess that we have the diagnostic information available to us to be able to fix compatibility issues, which is also something that we need to focus on. And that's like plenty of content, I think, for devlogs, if you guys are interested in that. Right, now let's kind of take a look at the second profiling thing. So I'm gonna keep this open because I was very lucky to get a spawn above ground in this version. And I'm gonna launch something called Tracy. Now Tracy, we used to use Optic for like profiling, but now we use something called Tracy because it's just a lot better. And so what I can do here is I've just opened it and you can see it's already discovered that this is running. This is just on my local like computer, obviously, but I can actually connect this to anything. Like if I was running this on a different device even, or on a different computer, you can just connect kind of, I guess, over TCP. So it's actually really good in that. So if I just click on this, you can see it immediately starts running. Let me just kind of zoom out here because it's a little fast. You can see kind of in real time, like look at this CPU usage graph, like it's just full on running like in real time. Now the performance has dropped a bit, that's to be expected because it's obviously streaming all of this information. So you just have to be careful with that. Sometimes numbers will inflate to unrealistic values because maybe your instrumentation is just too much, which is why like, honestly, I don't know why we haven't done this yet, but it's generally a good idea to add like a different granularity of instrumentation. There might just be like, I just want the overview, meaning like how long does this take, how long does that take, but not like how long does each individual render like submission take, because that could be thousands per frame and that can be really, really expensive. But anyway, if I just like hit pause arbitrarily here, if we kind of just open this up and zoom in a bit, we can just, yeah, start kind of dissecting this information. So I'll kind of zoom in so I can show you what's going on. We have the main thread up here, we have the render thread over here, we have the audio thread, as I mentioned here. You can see it's not really doing much. I believe this little blip here is the actual work and the rest is it like sleeping and waiting. We have memory usage, I guess, per frame as well, which is very interesting. CPU usage, which by the way is tiny, like 3.3% is like the upper bound here. And if we take a look at this, we can also see where we're bound here, the main thread or the render thread. And you can see, unfortunately, that this is showing that the render thread is spending a lot of time waiting. That is obviously a little bit different to the timers we just looked at. Why? Because check this out. We have quite a lot of functions here, 2,344 function calls just in this kind of block that you can't see, that are all obviously instrumented, that are all trying to submit this data to Tracy so we can take a look at it. And unfortunately, that means that it's slowing it down, which sucks. And I wish there was like a better kind of solution for this. This is still like the overhead of Tracy, as far as I'm aware, is much lower than Optic, which is great. That's part of the reason why we switched to it. But it's still obviously not zero or not very, very minor because you can see how much it's blown up this time. But either way, if we just zoom in a little bit, we can still kind of see what is potentially slow here. And you can see there's two kind of parts here. There's the get world space transform matrix, which I just know from experience has to go through like and traverse all of the parents that you might have for any given entity. And it has to do a bunch of kind of matrix multiplication to kind of work out the actual world space matrix from all of the local space matrices. We don't do this in a good way currently. Like we literally just work it out every frame from scratch. There are much better ways of doing this. My kind of big plan to speed this up really is just to have like a separate component that holds the world space transform matrix. I'll probably go deeper into that in a different video. Look at that, coming up with lots of devlog content. But that's definitely part of the problem because you can see we have to do that for every single static mesh that we submit. And obviously, like if the hierarchy is deep, which it isn't actually in this game, that's why you're only seeing like one or two here. But I'm pretty sure what happens is, for example, every like hexagonal tile that you saw that made up the world, that actually gets added to like, here is my world chunk or something. And the reason why it even does that, like I think it's primarily honestly for organizational purposes. Like in the editor, it's nice to group them so you don't have your scene hierarchy just with lots of stuff because you can just collapse your chunks and you don't need to see all the tiles that make up that chunk. That being said though, like if we're really talking about optimization, it shouldn't even be like one entity per like tile. Like that's weird as well. This was obviously a game jam game. If we were actually properly wanting to like develop this game and optimize it and ship it, we'll probably write like a world generation system in C++ that just, I don't know, batched the geometry together, or at least like maybe it would still use instance rendering, which is what it does at the moment, but just wouldn't treat them as separate like game entities because that itself adds a lot of overhead that is unnecessary considering they're just static meshes that, I mean, are also used for physics, obviously, because we need to walk on them, but still still, it's a bit of a different story. So that I would say is probably the biggest bottleneck. We can also see, by the way, I'm gonna just close Tracy for now. Again, really cool, really useful, but sometimes if you go too fine grained with it, it's not as useful, unfortunately. I'm gonna have to close this, which makes me scared because it'll probably be hard to get another above world spawn. But if I just go into runtime layer, we have some more like fine grained timers here. Here it is. It's in this if false block. So if I just turn that on for a bit, what this lets us do is if we go into like scene, and let's just say we wanted to find out information about that world space transform, it is profile. This is what adds the instrumentation. But what I can do is HZ scope, and then there's perf or timer. I don't quite remember the difference. Perf is what I want. So scope perf, and then I can type in a name. So let's just like, I don't know, copy this and put it in here. So if I rebuild now with this, I'm gonna get an on-screen timer that shows the cumulative time that this took, right? So the total time that this took per frame. So across all the times that this was called in a single frame, how much time did that take? So Control F3, you can see there's way more timers now. Might be a little bit difficult to see because some of them are changing. Oh, I got an above world spawn. Here's our get world space transform with 0 milliseconds and only 8 calls. Okay, that's the wrong function, unfortunately. I'm gonna have to run this again. Yeah, get world space transform matrix is what I wanted. So this is the guy. Let's just redo this. We'll run it again. I guess we don't have to be above the ground though to look at these numbers, but still it seems very, very fast. 0.002 milliseconds, but for 4,723 calls in a single frame. By the way, this is also very concerning. 4,700 calls to asset manager get asset. Like that is a lot, but it seems extremely fast. Like 9 microseconds here and 2 microseconds. Like, I don't know if I can trust these numbers. I feel like I need to dig deeper here because I just don't believe that it's that fast. But it's difficult because I do know that these, like the entity hierarchies here are not particularly deep. So I guess it is possible that it's like if there's an early out, it's probably hitting it because that's a lot of function calls. And if we take a look at what that function does, I mean, it's going to recursively kind of go through if it has a parent, but if it doesn't, I mean, it's still going to have to go through try get entity with UUID, which is going to try and find the actual entity by its UUID, because it's trying to look for the parent. But if it doesn't hit the parent, then it just does this matrix multiplication, which would just be identity times the actual transform matrix, which it also has to assemble, by the way. So I don't know, that's a bit sus, like as if it's that fast for like 4,700 times. To be continued, I guess. All right, anyway, I'm gonna end it here. Hope you guys enjoyed this devlog. Let me know if you want to see more of this kind of thing. Again, I didn't really have an idea. I just like did a little poll, as you saw, just like listed some topics off the top of my head, and we wound up with this video. So honestly, if you guys could let me know what you liked about it, what you didn't like about it, if you want more content like this, but maybe, I don't know, slightly different or exactly the same or whatever it may be, please let me know. Don't forget that you can get access to Hazel and also help support its development by going to patreon.com/thecherno. And I will see you guys next time. Goodbye.